These are the Unit 1 notes for the Finding Limits 1 worksheet. To start with these notes, we're going to rewrite the derivative of the function at c. And let's just remind ourselves what this means. We have a function here, looks sinusoidal. We have a point that I'm interested in. I'm interested in knowing how quickly this function is increasing or decreasing at this point. The x coordinate of this point is c. Method 1 for doing this is to draw a tangent and figure out what the slope of the tangent is. I can do that paper pencil. I can get a rough estimate by using my ruler, but I can't do that computationally because there's no way I can find the slope using just simply one point. So I'm going to pick a second point, and this second point, its x coordinate is x, and I draw the secant that goes between these 2 points, and then I find the slope of that secant. And if I bring this second point in closer and closer to the first point, the slope will change. And if I pay attention to how that slope is changing, I can figure out what the limit is, what it is approaching. And in that way, I can figure out what the slope of the tangent is going to be, even though I can't compute the slope of the tangent. So again, we're going to rewrite this formula. I'm going to do it quickly here. Told you it'd be quick. So here it is. Here's the formula once again. I would like you to write it down. You might want to pause this video so that you can write that down. And then, just as way of reminding ourselves of how this limit definition works, I've pulled up the little sketch I showed you in class the other day. Here's my point that I'm interested in. I have my second point over here, so we have the x coordinate of this point is c. The x coordinate of this point is x. I'm taking this point and I'm moving it in, bringing it in closer and closer and closer to c. As I do that, you can see that the slope of the secant that has been drawn in here is changing. And what I'm paying attention to is what I think, or what I'm observing, the limit of that slope is going to be. And you can see here it's negative 0.84, negative 0.83, negative 0.8, negative 0.7978. And as I get in closer and closer and closer, I have a better and better idea about what this slope is approaching. And then you can see here, if I can get this to line up, when my second point approaches my first point, then I can no longer compute the slope, which is why we need to be looking at the limit. And I can come at it from the other side as I come at it from the left, heading right towards this point, and we can see that it's looking as if the slope here is approaching, so probably negative 2/3. Now, since we're doing computation here, we're going to actually take a quick flash forward and look at this formula for the derivative with a particular function. And here we're looking at the function x squared. And over here on the right hand side is a graph of x squared. We're going to pick a point on this graph. If we pick the point negative 2, 4, right? So we're going to look at it right there. And what I'm interested in is I want to know how quickly this function is increasing, or actually, excuse me, it would be decreasing because we're reading from left to right. How quickly this function is decreasing right here at this point. Right? So again, the definition for this, and I'll do this quickly. So that's the definition. You've just written it down probably now the fourth time we've written this down. Must be pretty important, huh? So I'm going to take, since I know the function and I know the point that I'm looking at, I'm going to rewrite this using the specifics that I'm interested in. So I'm looking for the limit of the slope of the secant, and I'm taking my point x, and I want my point, I'm taking the value x of that second point, and I'm bringing it in as close as I can get it to -2, and f of x is this function right here, so that's x squared minus f of c, well, that's the y value of the point that I'm interested in, that is 4, right? So we're right over here. This is a point that I'm interested in. Its coordinates are c f of c, or in this case, specifically, it's -2, 4. So the y value of my x point, I don't know where that the y value of my second point, don't know where that is, but it's defined by the function x squared. The y value of my first point is 4, and then we're dividing this by the x value of that second point, which is x, minus the x value of the first point, which is -2. So minus -2. And now you should be having a flashback to pre-calculus. So we're just simply doing a limit. And it's actually a pretty straightforward limit, because what's happening here, I'm going to rewrite this, and as I rewrite it, I'm going to factor this. All right, a little bit of a mess up here, but we'll rewrite this for us. Okay, so again, I'm going to factor this. So the numerator factors into x plus 2 times x minus 2. The denominator is x plus 2. And you'll notice as the x gets closer to -2, or actually when x is -2, the denominator is going to be 0, which means we will not be able to find the value of this expression. Right? If you remember from pre-calculus, what this means is that because we have an x plus 2 here and x plus 2 here, on the graph, if we were to graph this, you have a hole. There is cannot be evaluated. But we can, and I'll choose a different color here, we can notice that we have an x plus 2 here and an x plus 2 there, and those reduce to 1. So then what we end up with is the limit as x approaches -2 of this simplified fraction, which is just simply x minus 2, and using what we knew about limits, we can evaluate the derivative, and we find that when we plug -2 in here, -2 minus 2 is -4, which means that right here at this point, the derivative of this function at this point is -4. The slope of the tangent line at this point is -4. Right? So the moral is that evaluating derivatives exactly and elegantly as above requires being good with limits. So that means we're going to have to do some review, or it would be good to do some review of. So first, just a reminder of what a limit is. So this function, f of x, is going to get really close to, and when I say really, I mean like really, 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 really close to L, as x gets really close to c. All right? So I'll put that in words for you. You can pause the video and all right, and then just a quick little note here on the bottom. There are a couple of what we refer to as discontinuities that you need to be aware of. The first one is what's referred to as a point discontinuity. So this is my xy axis. I have some sort of function here. If I have a hole here, and then the value of the function appears up here. So what I've got is I've got at, let's call this 2. Right? So at 2, as we're approaching, as this function's x coordinate is approaching 2, it looks like we're approaching, well, let's call that, we'll call that 3. It looks like the function is approaching a value of 3 as we're coming from the left of the x value of 2, and as we're coming from the right of the x value of 2, we are also approaching 3, even though at 2 we have no value, or actually we have a different value for the function. Right? So in this case, the limit as the function approaches 2 is 3, even though the value of the function at 2 is something different. The second kind of discontinuity is what's referred to as a step discontinuity, and you have your function coming in from the left. It is approaching this point here, so we're at the x value of 2, and then when you get exactly at the x value of 2, you end up with a jump, and the function heads off this way. So what you have is, as you're coming at your point of interest from the right side, here we'll put a couple values here. Let's call this 3 here, and then up here we'll call this 4. So as you're approaching the value of 2, your limit, right? So the way we write this, as x is approaching 2 from the right side, that's that little plus on the back end of the 2 means, the value of the function is equal to 4. But now as we're approaching the 2 from the left side, negative here to note that we're coming from the left side, the value of the function is 3. So coming from the right, it's 4. Coming from the left, it's 3. And what we say then is that the limit of the function itself as it approaches 2, right, is undefined. Or in Friedland speak, we make a little frowny face.